In today's lesson, we will graph transformations of parent functions for tangent and cotangent using key points. Before we begin, let's examine this tangent and cotangent graph. Notice that the tangent has a positive sloping graph while the cotangent is negative. Also notice that tangent, a full period, ranges between negative pi over 2 and positive pi over 2. Whereas cotangent, a full period goes from 0 to pi in those same intervals. Also notice the intercepts. Tangent has an intercept at 0, 0, whereas cotangents are at pi over 2 and multiples of pi over 2. Let's start with looking at tangent. Here we have our regular tangent function, and then we have a couple of transformations. By now, you should know that this 2 is a change to the amplitude, and the second 2 is going to be a change to our period. Let's first look at our key points for our tangent function. I have put in these theta values based on our parent function. If we go back, remember I said that we can look at one full period between negative pi over 2 and positive pi over 2, which is what I have listed here, and I have done it by quarters. So every quarter would be an increase or a decrease of pi over 4. If we go to pi over 2, which is down here, we know that tangent represents y over x or sine over cosine. If we look at y, we have negative 1, x is 0. We can't divide those, we get undefined. Next, if we look at negative pi over 4, that's right here at 7 pi over 4. We subtracted 45 degrees, or pi over 4. The exact values there are pi over, or root 2 over 2 and negative root 2 over 2. If you divide those, you get negative 1. At 0, y over x is 0 over 1, which is just 0. And then you can see at pi over 4, we have the same values here, except they're both positive. And at pi over 2, again, same thing, we're going to be having division by 0. That's undefined. Anywhere where we see undefined, that'll be an asymptote. Notice at negative pi over 2 and positive pi over 2, if I come back here to my graph, you can see that I could draw in an asymptote here, and I could draw in an asymptote here. And my tangent function, the end behavior, would come up and get very close to that asymptote on either end, but never cross. Let's go ahead and apply these transformations. The first one, the 2, that's an amplitude change. That impacts our y values, how high or how low we go. So instead of having negative 1 right there, we would have negative 2. And instead of having 1, we would have 2. Okay, what about the 2x? That's our period. Our normal period is pi, meaning we complete one full rotation in pi. But if we divide this by 2, that means we're going to complete one full rotation every pi over 2. Okay, so that's going to change our thetas. The easiest thing, though, is to start with 0, 0, because at 0, we still have 0 here. Now, what we know is that every pi over 2, we're going to complete a full rotation. We need to know our quarters. So if I multiply this by 1/4, we know that we're going to have quarters every pi over 8. So we're starting here with 0, 0. We have a point here at 0, 0. We would want to subtract pi over 8 to get our next theta. So instead of being at negative pi over 4, it's now at negative pi over 8. Then we would want to subtract another pi over 4, which would leave us with negative 2 pi over 4, or, negative 2 pi over 8, or negative pi over 4. Going the other direction from 0, we would then have pi over 8, and then pi over 4. So what I've done is started here at this center point, because I know at 0, 0 I'm going to have the same point, and then I've subtracted a quarter each time, and then added a quarter each time. So here we would have undefined at negative pi over 4, and undefined now at positive pi over 4. I'm ready to graph my tangent function. So what I'll need to do is draw in my thetas using these values. Now that I have my axes labeled, I'm ready to plot these points. Before I go ahead and plot these key points here, let me draw in my asymptotes. Drawing in these two asymptotes will give me a guideline for my end behavior. Now I can plot negative pi over 8, 2, or negative 2, right down here. I can plot pi over 8 positive 2 right up here. And you can see, here's my 0, 0, that through these 3 points, because I know the shape from my parent function portfolio, I'm able to draw in my tangent function. And remember that my end behavior will follow those asymptotes. I could continue this on by just adding quarters of pi over 8 to each value. So I would add pi over 8 to pi over 4 and so on and so forth in both directions, making sure that each quarter I have a tangent leg. Let's examine the cotangent. For our cotangent, notice again I've selected these angle values based on my parent function. Looking at my parent function, I can take one full interval from 0 to pi. I could actually choose any interval, but 0 to pi is probably the most simple. Therefore, I have taken and made each quarter all the way from 0 to pi. Now let's write in our values. Well, at 0, cotangent is now x over y, or cosine over sine. 1 over 0 is going to be our undefined. Pi over 4, notice right here, is 1. Root 2 over 2 divided by root 2 over 2. Then at pi over 2, x over y gives us 0. At 3 pi over 4, you can predict we have the same values as we did at pi over 4, except for one value is negative, so we have negative 1. And then we have undefined back here at pi. So how do we go about doing this transformation? This transformation, remember, means a shift left of pi over 4. That means all of our angles will shift left pi over 4. We'll be taking our cotangent and moving it to the left pi over 4. So we'll have these same y values, but we'll have shifted theta values. Let's go ahead and look at our first one. Let's start with our 0 here. If we have pi over 2 and we subtract pi over 4, well, this is the same thing as 2 pi over 4. So 2 pi over 4 minus pi over 4 just gives us pi over 4. So our 0 is now going to be at pi over 4. And then we can just keep subtracting. We can either subtract from this pi over 4, or we can look at each angle separately and subtract. We'll get the same answer. Pi over 4 minus pi over 4 is 0, and 0 minus pi over 4 is negative pi over 4. From here, we could add pi over 4, or again subtract from this angle. So this would give us 2 pi over 4, or reduced, that would be pi over 2. And then if we add another pi over 4, or we subtract from here, we would end up with 3 pi over 4. But remember, our y's have not changed. We have these same values here. So here's our thetas, and here's our y's. Now we can plot these angles on our graph. Now we're ready to plot our points. We have our axes labeled. Remember, the first step is to plot your asymptotes. So we have one here at negative pi over 4, and we have another one here at 3 pi over 4. And that will assist us by guiding our end behavior. Our first point that we have here is at 0, 1. We have our 0 at pi over 4. And then we have a negative 1 down here at pi over 2. And you can see by this shape, and again, looking at your parent function, you know that the cotangent will look something like that. And again, we could continue to add pi over 4 to make multiple quarters if we wanted. And that concludes our lesson on how to graph transformations of tangent and cotangent functions. Just remember that if you're able to graph the parent function, it's fairly easy to transform that parent function in order to get your transform functions.